What's
Hey
up,
everybody,
everybody? Hey, James.
says the stream is live. Welcome everybody. Can we see how many
hmm
people we have in yet? Do we have anybody? Looks like we have Jimmy Carter.
Excuse me. Yeah, we got Jimmy. All right, cool. Cool. Excited for today. It's gonna be good.
I think one of the
Wait.
things, yeah, excited, yeah.
Cool. All right. Well,
I think one of the things we noticed is that there's a little bit of a delay sometimes. So we got this housekeeping screen up, right?
right.
We'll do some introductions. I think you're going to introduce yourself and introduce me. But if you're just
Right.
tuning in, your camera and mic should be disabled, and then we'll address questions based off of the live chat, and we'll do that after the presentation. So register with your first name and last name. So
Perfect. All right, James. Well, I'm gonna get started, or let's do this thing. You ready?
let's go. Drum roll.
All right. Well, everyone, welcome to the first ever Q-PAC fan architecture webinar. My name is Salem Homringhausen, and I am one of the field marketing engineers. And James, if you want to introduce yourself.
Yeah, I'm James Montgomery, field marketing engineer as well. Salem and I work together, proselytizing about the Q-PAC systems.
Exactly. That is our goal. We are the educators, and we mainly focus on educating and applying the Q-PAC fan. So I'll jump right into it. This is our facility in Elkton, Florida, just outside of St. Augustine, Florida. It's a 46,000 square foot factory where we build all the multimotor plenum fans. That's what we do at Q-PAC. We design and build fans for commercial air handlers. We've been doing it for about 13 years. The purpose of this webinar is really to kind of educate everyone and give you an update on where we're at now. So I'm going to start out with a little bit of history here in a minute. First, we have done about 9,600 fan systems since 2019, and we've sold over 45,000 ECM plug fans since that same time period. And there's currently 82 Q-PAC employees, and we're growing. So yeah, back to what I was saying though. We're going to, I'm going to take you through the history of Q-PAC a little bit, kind of show you how we started and then what we've become. And that's going to that's how we're going to go through this architecture. So this is the first ever Q-PAC ECM fan array. This was in 2012. Basically, we just had a sheet metal wall and 3 ECM plug fans. So the idea was we were modifying semi-custom air handlers, and we discovered these ECM plug fans, and they were being used for things like fan coil units and smaller systems where they were the only fan in the system. And we realized that we could extrapolate their performance to a larger system and use multiple of them. So we had a whole team of mechanical engineers that were working in SolidWorks and designing these by hand, and it was all very custom at the time. In 2015, we invented the fan replacement kit for them. So basically, these are all going into new air handlers, and we determined there's a need for a fan replacement solution as well. So instead of just going into a new air handler, we wanted the option to go into an existing air handler. So this would just ship knocked down to the job site, and the mechanical contractor would install it after they finished doing the demolition of the existing fan. So it's kind of those break fix it applications. In 2017, we introduced something called the Quick Connect box, which was a junction box that basically consolidated all the power and controls wiring for the ECM. So in this example, there was still a decent bit of wiring that had to be done by hand here. And it was all run directly to that Quick Connect box. So at least the electrical contractor on the job site would have an easier time running the power and controls to that box as opposed to each individual ECM. We also had a Modbus protocol that we had to use for each one of the ECMs. So they had to be daisy chained together, and they had to be addressed. And at the time, it was the best fan array system out there. But by today's standards, it was a bit outdated and certainly a little cumbersome to install and work with. Then in 2021, we introduced FS1, which was kind of the next step forward. So you can see that that Quick Connect box there is got a bit of an overhaul. There's these plug and play, hate to say that phrase, but it is really appropriate here. Fan harnesses, they're going to connect wall harnesses that will connect the ECM plug fans directly to the Quick Connect box. There's actually a little ledge there on the bottom of the mounting plate of the ECMs. And it really just reduced the complexity of the product. So we really started to realize that this was more than just a fan array. So that was kind of the first step towards that. And we also removed the addressing feature. So each one of these ECMs could be swapped out for any other one of them. But before we go further, I'm going to ask you guys some kind of higher level abstract question to get you thinking about some stuff. So what is a fan, right? If I ask you that, what are you going to say? I think a fan most people say a fan's got an impeller. It's got a motor. You're moving air. You're rotating an impeller and you're moving air, right? That's what a fan does. That's what it is. But another question is, can a fan be made of many fans? So, more holistically, can a thing be made of many of the same thing? And I would say yes. And let me give you some examples. So I would call this a power tool battery. I think anybody out there would call this a power tool battery. It's what you use to power a power tool. But if you open it up, you see that it's a battery that's made up of a bunch of smaller batteries. So yes, a thing can be made of many of the same thing. You can have a new type of battery, in this case, a power tool battery that relies on many smaller battery cells working together. Same thing for a tower fan. So here's an example where there's a single point of power and there's one single point of controls. There's a potentiometer basically on the side of the tower fan that allows you to dial in a specific fan speed. And there's multiple fans on this tower fan. So this happens frequently in lots of products. So it's not something super new, but we think when you apply it to commercial air handling units and fans for those commercial air handlers, you really have a new category of fan, what we're calling the multimotor plenum fan. The multimotor plenum fan is a new category of fan. Basically, the idea is that we productized this ECM fan array. We consolidated all the scope that used to be required. There's no more, you don't have to deal with a sheet metal contractor. You don't have to deal with a controls contractor, potentially. You don't have to deal with coordinating between multiple stakeholders. You don't have to worry about a control panel manufacturer and an ECM plug fan manufacturer. You just go to Q-PAC. You can get that fan tailored to your specific air handling unit. So that's the main thing here. The fan controller really is the piece that kind of tied it all together. I'm going to get a little bit more into that stuff here. Again, we do have this online configurator that we didn't mention earlier, but basically allows you to configure the product in seconds as opposed to it taking hours previously. It's one of the other easy features that allowed us to do this. But as far as the main features of the product, you have your Q-PAC fan frame, you have your ECM plug fans, the fan controller, and then the harnessing, right? And that's what kind of makes up your multimotor plenum fan. Before we go any further, I just want to give you guys a quick idea of what the performance looks like for these products. So 5,000 to 90,000 CFM, that is going to be your airflow performance window for a single multimotor plenum fan. They're going to be able to do 1 to 9 inches of total static pressure as well. So I basically say that if you're looking at an air handler and it's 5,000 CFM or up, or it's between 1 and 9 inches, and it's between 1 and 9 inches of total static pressure and water column, then a Q-PAC fan will work for that particular system. Now, there are some limitations on the width and the height of the product, but the way we size these and the way they work physically, your performance is always going to be somewhat related to the aspect ratio of the product. So just knowing that performance point is really a good start to begin sizing and working with this product. Back to my previous comment, there's the 4 pieces of the fan. So there's that fan controller there on the left. There's the Q-PAC fan frame as well, which we used to call the bulkhead wall, a bit of a change in terminology. There's the ECM plug fans or motorized impellers. And then there's the frame harnesses that are actually going to connect from the fan ledge there all the way over to the fan controller. First piece of the product, the fan frame, the Q-PAC fan frame, is it's all sheet metal that's formed at Q-PAC. So we're doing all the bending and the punching here. And it's an adaptive frame. So basically, you tell us what the width and height of the internal dimensions of the air handler are, and we're going to size the product to those dimensions. So you don't really need to use a sheet metal contractor to install a wall around your fan. That's a nice piece of labor that you can remove. The Q-PAC fan frame effectively is the pressure wall. So it's just kind of a juxtaposition on the way you'd normally think about a frame. So it's also going to have those harnesses on it, and it's going to have the fan controller as well. So when you're talking about the Q-PAC fan frame, you're just talking about the specific sheet metal wall that makes up our frame. The frame is holding the ECMs, or the multiple motorized impellers. The fan controller. So this is really the brains of the product and kind of what has enabled us to re-architecture everything. So the fan controller currently, it started out as that consolidation point for all the power controls, and it has evolved into a product that actually does control the individual motorized impellers. You're going to get an individual overcurrent protection for each one of the phases of each one of the ECMs. You're going to get other features as well. There's individual pressure transducers per ECM plug fan, and there's also a pressure transducer on the main board, which is something we'll take a look at here next. So this really right here is the heart of the fan controller, and it's the printed circuit board that our team of electronics engineers, Q-PAC has about 6 or 7 full-time electronics engineers that developed this product, and basically it's laying the foundation for the future of this technology. We have this board mounted pressure transducer that's going to give you the Q-PAC fan level airflow. And also the main thing about this is that we really decoupled the Q-PAC fan from the control panel. So previously you would need to have a control panel every time you wanted to order a Q-PAC, and it would become kind of this system. There was more pieces than just the air movement device that was required. Now you can actually just purchase a Q-PAC fan, and you can run power and controls right to it. So currently all you need is 3-phase power and a 0 to 10 speed signal, and you can actually run the Q-PAC fan, and it's going to take that 0 to 10 speed signal. It's going to distribute it out in parallel to all the other ECMs. So they're all going to ramp up and down at the same speed currently. There's a lot of future development that's going on with this board. It's going to enable a lot of more fine-tuned control of the product. I really kind of compare it to if the current product or the current architecture is like a fist that's pushing the air through the airstream, then the fan controller board here is really paving the way for more of like a hand with fingers. You're going to be able to have a little bit more fine control over that airflow as it moves. Currently, it can communicate with RS-45 conductors over Modbus, and that's going to be how you can get your individual ECM plug fan status. You can get your Q-PAC fan level airflow, and you'll also be able to get an alarm relay as well that tells you whether there's a failed state or not. So the plug fans themselves, it's a fully assembled ECM plug fan assembly that is going to come from the 3 major German manufacturers that we work with. So that's Labeg, DBM Pabst, and Rosenberg. And what that is comprised of is a mounting plate, a structure for actually mounting the physical motorized impeller to the mounting plate, and an inlet cone as well. So since the assembly is manufactured at those German manufacturers, the whole product is actually balanced and tested at their factory. So these individual ECM plug fan assemblies are balanced at the factory, and they don't require any matching and mating of the motors to those impellers. So that's kind of already done for you, and you can even just look at it as a total input power, so to speak. You don't really have to need a brake horsepower as much. And there's also 480 volt versions, and there's 208 volt versions. So there's a total of about 13 or 14 standard ECM plug fans we offer, and that's what allows us to comfortably optimize our product for that entire airflow range from 5,000 to 90,000 CFM and 1 to 9 inches of static pressure. So the control panel, as I said before, this is a product that we had to start building basically because we wanted a little bit more control over the controls for the building and how you would actually operate the Q-PAC fan. And as it was a requirement previously, now it is optional since the Q-PAC fan can be operated just with that power and control signal. But currently the control panel is a great option for people, especially if you have a building that's maybe not as sophisticated. Maybe it doesn't have a very sophisticated BMS system that's really controlling your airflow or reporting many values. You can actually use our premium controller that has the PLC and the HMI there to control the product. So you gain access to 2 different control types when you use the premium control panel. So there's a constant static pressure mode and there's a constant airflow mode. And the constant airflow mode, you're basically just going to put in the desired airflow level, and you're going to let it run at that. It's going to maintain that airflow. And then the constant static pressure operation is just you're going to input a static pressure value. Usually you can hook up a static pressure sensor from 2/3 of the way down the duct, and that's going to go back to the control panel, and you can then program the HMI to tell the PLC to maintain that static pressure. So it's a pretty cool feature, and it's great for those folks, again, that don't have the more sophisticated BMS. It's going to come standard with a fuse disconnect, and it's going to have all the power, the electrical power infrastructure inside of it to manage that for your fan. Also, you're going to get BACnet as well. So there's a BACnet compatibility with the control panel. You're going to be able to see a bunch of points specifically. So that's going to be your individual ECM plug fan status, your airflow, your power monitoring, that type of stuff too. All right. So kind of the mission of Q-PAC right now, and I maybe should have mentioned this at the beginning, but we want this multi-motor plenum fan architecture to be the dominant architecture out in the industry. We think that this really is the best fan for commercial air handlers, and our goal is for there to be a multi-motor plenum fan in every air handler. And to that end, we're working much more with AHU OEMs and with more consulting engineers to drive the adoption of this product. And as a result, we are actually shipping the factory assembled version of the product now to OEMs. So basically, we can combine it at our factory. We can fully assemble it, and then we can ship it out assembled so that the OEM just has to pick it up out of the crate and then drop it right into the fan section of their air handler. So leaning up that manufacturing process is a big value add that we provide. But traditionally, the product does come knocked down. So, back on those earlier slides, I showed you the first Q-PAC fan array that was out there in 2012. We built a palletized version in 2015, and the shipping and packaging of the product developed as well. So now it's kind of laid out as you see in the slide here. You've got your frame panels, your assembly hardware and harnesses, all with the fan controller on the first pallet. Your control panel, if you have that, is going to be on the second pallet, and then your ECM plug fans will ship in stacks of 2 and any additional pallets. So the product is really modular, and it's going to be great to get into a service elevator to get up to a mechanical room if you're in a tight spot, which is another one of the values of the product for the fan replacement side. But additionally, you could even use this as a solution for knockdown new air handling units. Let's say you have a knockdown air handling unit project that you've worked to get your favorite custom air handling unit specified for. You could specify Q-PAC as the fan, and it's going to show up palletized just like this to the job site with those brand new knockdown air handlers. So there's lots of adaptability and agility with the product delivered this way. Another thing is the multimotor plenum fan will go from 5,000 to 90,000 CFM. But the actual product, you can kind of think about it as an array of multimotor plenum fans potentially, but with a lot more intuitive and an intuitive sense to it, where you're going to be able to use multiple MPFs in an easy way together. So basically, you can go all the way up to 230, 250,000 CFM, higher than that. It really just depends on the scale of the project and how many ECM plug fans you need and how many MPFs you need. So, I would say as a starting point, if you have a project that's exceeding 250,000 CFM, or if you have a project that's really exceeding 90,000 CFM, that's something you're going to want to work directly with Q-PAC on. So as the scale of the job gets up and then the higher performance ranges, that's just something you want to reach out to our team on. But it is possible. So any CFM, as long as that static pressure is between 1 and 9 inches. Certifications, we do have certifications, UL certifications for the Q-PAC fan, the fan controller, and the control panels. They're all there on the slide for you, but what's a little more interesting is the AMCA 270 and the AMCA 204 standards we're working on. So the AMCA 270 is going to allow us to empirically derive the performance for each individual MPF. So we're actually building this wind tunnel, and it's one of the largest AMCA 270 rated wind tunnels that's ever been built, is what I've been told. And once it's completed, we're going to be able to test many configurations of MPFs to really determine that exact performance profile. Q-PAC, we really want to really understand, really have this fully engineered. We want to really know what is the performance for multiple multi-motor plenum fans. Like, if we aren't sure, then we want to determine that. And the previous method of extrapolating out the performance, for one ECM plug fan for multiple, we want to make sure that we want to verify that is still valid, and we want to be able to do. We want to potentially run each different ECM plug fan at different speeds. There's a lot of testing and thinking and curiosity that's going to be explored once we get this into our facility. So we're excited about that. So another thing we launched recently was the Q-PAC fan configurator. So I'll get into our specific software equips that we've had for a while, since 2018. But back in February, we launched the Q-PAC fan configurator on QPAC.com. So you can actually go right to the website. One of the first things that's going to pop up is that design your fan button. You're going to click design your fan, and then you're going to put in that airflow in CFMs, the total static pressure in inches of water column, your internal width and height in inches, and your supply voltage level, either 208 or 230 or 480. Once you put those inputs in, you're going to get basically a submittal you can print off for that particular MPF model. And you can even request a quote as well. So, that would go to our customer success team. They're going to handle it from there, determine whether or not in which way we'll work with you. But you get all that right away. It's going to basically optimize the Q-PAC fan selection that we think is best for those particular set of inputs, and you'll go from there. So, but Quips is kind of the more advanced tool, and this is something that will be available to people kind of on a request basis. It's something that we determine who we give access to internally, and it's going to have a lot more features. So Quips itself allows you to input those same parameters, but you're able to choose between a lot of different selections. So given some set of input parameters, you'll be able to select any number of, between 5 and 10 potential solutions for that air handling unit, and for the particular fan you want to configure. So a lot of times we have those 13 ECM plug fan models, and each one of them kind of corresponds to a benefit to the end user. So certain ECM plug fan models might be a lower weight. So you want to optimize for a lower weight. Let's say you might have a facility manager that has a really tight team, like he's got 2 or 3 guys and that's it. They're kind of bare bones, and he's got 10 buildings to run. So optimize on a lighter weight ECM plug fan so that his guys don't have to do as much maintenance. On the other side, you could also optimize for larger ECM plug fans that have the highest possible FEI. Let's say that this is a really big energy project where we want to save as much energy as possible, and you're going to want to optimize for your FEI. Or if it's another fan replacement project, you might even want to optimize on the MOCP or the existing electrical infrastructure. So in those cases, you want to make sure you match that MOCP to your existing electrical infrastructure. So the ECM plug fan data, the Q-PAC fan data that's going to show up here when you're going through Quips is easily downloadable as well. You get kind of a nice little a nice snapshot of what's going on with this particular system. And then right after you click the possible selection and you choose your selection, it actually will show you how it's going to show up as well. So it shows you the distribution of the plug fans on the Q-PAC fan, and gives you your dimensional information as well. So the last thing here is when you're using Quips, you can use it as a project management tool as well. So you can actually order your product through Quips. But you also have your submittal and your quote available right there for you as well. So you can download those with assembly drawings and your 3-view. And basically you take that design time that you might have had to reach out to the manufacturer for, and you greatly reduce the design time. If you can do it yourself, you can get it in a matter of minutes. That's a lot better than having to wait a week or more potentially to hear back from a manufacturer. So that is it. That is the Q-PAC Multimotor Plenum Fan Architecture webinar. We'd love to take some questions. I think James here is going to take a look at the chat and see what we got. So James, I'll hand it off to you from here.
All right, good job, Salem. Way to get this information out. It looks like we did have one question from, I may butcher your name, but it looks like Khalid Rabani. He says, do you have a smart starter allowing start of one fan at a time? I think that if I can, I'll take this one. Traditionally with AC motors, there's an inductive kick when you start a single AC motor. That's due to a couple of reasons. One, because of the energizing of the coils, but also because of the large mass and rolling mass of the shaft and potentially impeller and or coupling that's attached to that. These fans are internally driven. And because they're internally driven and there's almost zero rolling mass, it's really low, these things are soft start. And so while there will be a slight indication of a current uptake or almost like an inductive kick when you start these fans, they are soft starts, similar to what you would see with a BFD. I hope that answers your question, Khalid. If you had any specifics, feel free to ask some trailing rods. Another one comes from Matt. I'm not even going to try to say his last name. He says, and I'll let you take this one, Salem. He says, when is the non-control panel system available in Quips? Good question.
All right. Hey, Matt. And that's Matt Sapaniak from Florida Applied Products. Thanks for tuning in, Matt. We appreciate it. The MPFs will be selectable in QUIPs. The date is supposed to be July. So I was told early July, but I'm just going to give it July. That should be when you can get the MPFs available in QUIPs. And there's also going to be an option where you can choose an electrical disconnect. So, if you do want to have that disconnect, I know it's an NEC requirement, you'll be able to get one from Q-PAC if you need one and you don't want to go elsewhere. So that'll be another option. But yep, July. Thanks, Matt.
All right. Yeah. Thanks for the question, Matt. And Khalid responded. He says it does. Thanks. So we answered his question. Salem, there's a couple things that I wrote down since we don't have a lot of questions. I'll give some people, I don't know, a few more minutes to talk about or to question some of the things. You were talking about the adaptive frame. And I'm just curious, how has that evolved, Salem, and what considerations, were considered when we've evolved that specific piece of the Q-PAC system?
So that's a great question. It was a little before my time when we did the final design for our adaptive frame. But in general, there are different types of adaptive frames. I think it'd be nice to have one of our fan engineering guys on for this, but in general, there's 2, 3, 4 different types of fan frame, and they're basically it's based on how much space you have available. So I was talking earlier about how the product is sized based on performance point. So let's say you have a 45,000 CFM air handler. It's 3 inches of total static pressure. It's 480 volts. As the aspect ratio or the width and height of the internal dimensions of the unit gets smaller, you actually have to fit more airflow into a smaller space. So the ECM plug fans begin to take up more and more of the available aspect ratio or the available cross section. So you basically have to just make a much smaller frame. So the idea being, the more space you have, the more structural panels will be available on the adaptive frame. The less space you have, the fewer there will be. So we do, there is a kind of a sweet spot where, you really want to have a little bit more structural panels on the project as needed, really. So.
All right. Yeah, I still don't see any additional questions. So just another theoretical, and this is more of a thought one. So Q-PAC starts making fan arrays, and we believe the natural course of that is the evolution to the new category of MPF. So if fan array was the beginning of this journey, then does that make MPF the end?
I don't know. I think that it seems like it's the next generation of air movement device that looks like this, and I think that we've kind of got a good handle on what that's going to be. And maybe something changes. Maybe one day we don't have air handlers. I don't know. The world is. I'll leave it to our R&D team to ponder on that one. But for now, I think it's a super strong category, and it'll be the future for the foreseeable future. So.
Nice. And last one for me is how does Q-PAC work with or help consulting engineers?
So I think typically the consultant's job is to be the advisor to the end user, right? So if you're someone who wants to build a new building, or you want to do a large renovation project on your building, then you hire a consultant, an MEP firm in particular, to advise you on how you make this thing work. And so it's their responsibility to make sure they're picking the best technology, and they're really building out the HVAC infrastructure for that particular building. So I think in general, we just kind of tell them about the benefits of how the multimotor plenum fan works in air handlers, and you can save a lot of space on the air handler. Again, it depends if this is a fan replacement type of project, or whether this is a multimotor plenum fan that's going into a new air handler. But if it is a new air handler, for example, you're going to save a lot of space potentially on the new air handler. You don't need as much distance between the Q-PAC fan as you and the coil section potentially as you would with different fan technologies. Additionally, you're going to have that inherent redundancy in the product when you have multiple motors, which can actually be configured to ramp up when you lose one potentially. So yeah, I think it's about communicating that value to them and making sure that they have it if they need it.
All right, thanks. Well, I'm not seeing any additional questions. We'll give them maybe, looks like we're at the 30-minute mark right now. So Sam, if you'd like to conclude it, we'll give you the last few seconds to ask a question and then we'll move forward. Thanks, everybody.
Sounds good. Yep. Thanks everybody for showing up and coming. And if you have any questions you want to take offline, feel free to reach out to James or myself. You can reach me at salem@qpac.com. So that's SALEM at q-pac.com. So any offline questions, feel free to reach out directly.